Hi, Chris.
Hey. So I couldn't work out how to do a background like yours in the end. Not experienced enough with Teams.
Well, I saw Tom Wilkinson and I saw a colours of background and I thought, okay, I need to do a background immediately. So it was an unplanned background.
Right. Okay.
And also the wrong shirt worn as well, because according to my screen, it looks, it's like one of those.
Kind of looks like you're ascending a little bit in the background into the figure.
Indeed. So we'll give a few minutes for people to join.
Cool. Are you recording? It says recording has started.
Yes. I guess we need to give people permission. We'll need to notify people that the recording is happening. I think that was done this morning, so I'm guessing that the consent is propagating through to this event as well. So I think we're okay.
Yeah, no problem. Cool. All right.
We have a relatively small bunch, unless people are disappearing for their break. So we'll give it a few more minutes. I think there was quite a lot of parallels in the technical pitches, to be honest with you. So it's an interesting interesting selection, I think.
Yeah.
Okay. All great.
Does everyone know where the Google Doc is?
It's funny. I'm just popping that into the.
Okay, ahead of me.
No, not really ahead of you, but I think I'm going to start. I think it's worth beginning. Good morning, and welcome to the breakout session for data science. Thank you for selecting this breakout. The purpose is essentially to facilitate conversations between ourselves. So although I presented some things that may be of interest, there may be other things. I would hope there to be other things that people would want to discuss and chat. We were concerned about the size of the group, but actually I'm looking at who we've got here, and it's reasonably manageable to have a conversation, which is great. And I think, considering that we are, sort of 10 or so people, I think it is almost worth going round the table and giving one sentence each about our background and what we bring. And I'm going to be quite rigorous on that. So, but I do think it's worth doing an introduction, considering the number of people here. So, here we go. It's going to now grow to an impossible level, but here we go. So let's go for that. A bit of housekeeping. So I put a link into the chat, which is a shared Google Doc. Now everyone should be able to access that. So if you've got any notes or anything you want to type, you can, which is beyond just a little statement in the chat, you can go and put that in there. And Chris, my colleague here, is facilitating the conversation as well. So he's been listening for things. So I'm just going to go around the table, so to speak, people I've got on my screen. So Stephanie Gutierrez.
Hello, I'm Stephanie Gauthier. I'm a lecturer in energy and building background. I look at indoor environment, people, research interest, indoor air quality, and building physics, dampness, overheating risk in people. So I'm just,
Okay, so indoor air quality.
Yeah, that's one of them.
Right, that's what I'm looking. I'm looking for the. Looking for the label.
Yeah.
Indoor air quality. Let's go. Is it Kaizu? Or Kaizu? Good morning.
Kai Zhou, a research fellow in advanced neuroimaging, and I do MRI in multiple sclerosis, dementias, and neonatal brain injury.
Brilliant. So advanced imaging in various different applications. Great.
That's correct.
Francesco Shankar.
Hello, hi everyone. I'm an astronomer, and but I work with doctors as well, measuring blood pressure. So strategies for improving blood pressure measurements.
Okay, brilliant. Thank you. Hans-Michael Hatchie.
Hi, Hans-Michael Hatchie. I am a clinician scientist in respiratory medicine, and I am doing clinical studies, but also basic research. And the clinical studies is the WATCH study, where we look at a cohort of 500 patients with severe asthma. So lots of data from there. And also another study, which is the maternal environment in pregnancy study, where we're collecting biological samples and clinical data from mothers during a cesarean delivery, which we then study with multi-omic analysis, mass spec, RNA sequencing, proteomics, and other things. So data that I would like to have analyzed and work together with people.
Okay. Brilliant. So mixed data, including omics, plus also I guess you've got other data sets you're linking to, but in respiratory asthma specifically.
Yeah.
Jonathan Reisner.
Yeah, I'm a final year medical student, and I'm working on my German doctoral thesis at the moment, which is focusing on cardiopulmonary exercise testing, which in itself generates loads of data. And I'm just thinking about how to best save those data to then have them analyzed with the most data that the machine already records, rather than me deleting loads of data just so that I can comprehend them.
Okay, so looking for sort of data management, data solutions. Tina Roos.
Oh, yeah. So I'm in School of Engineering. I'm a mathematical modeling, and the bits in biomedical area that I've done, but I'm interested in more different things, are to do with vascular and lymphatic function in particular. That how to image lymphatics and how to say what you're seeing, how to assign function using mathematical modeling to the images you see. Okay. So the latest project we finished was the imaging lung lymphatics in particular. But we've also looked at the development of lymphatic system in different animal models. I'm modeler, yes. Physiological modeler, mathematical modeler.
Brilliant, thank you. The screen is changing in front of me. That's annoying, isn't it? So let's go for Edelson Fernandez de Orada. Sorry if I pronounced that incorrectly. This is a test in
not even I can do that. So yeah, you can just call me Ed. I work at the business school. I'm an electrical engineer. I work with operational research and healthcare modeling for a while now. By healthcare modeling, I mean finding models to use resources, improve services, reduce queuing for services, that type of thing. Okay. I've also worked on modeling patient pathways, so and finding the dynamics and how the pathways translate into outcomes. But I did that using Markov processes, Markov theory, but using the data to translate the patient data into the Markov models.
Okay, thanks, Ed. Right, we're going to speed up a bit because more people have arrived, but it's useful. It's really useful to hear what people have to say and where they're coming from. Otherwise, we're going to struggle to facilitate the conversation. So, Richard Giordano.
Oh, hi. I'm a senior lecturer in the faculty of. I'm in the School of Health Sciences. So I'm neither an engineer nor a medic, although I've taught in computer science departments, particularly at Manchester, and I supervise some PhDs in ECS. What I'm mainly interested in is in co-design, particularly the co-design of approaches so that patients can understand the data that are given to them, particularly when it involves big data. So what I probably would be doing in this breakout room is listening to people and seeing maybe some projects where I could get involved. Some of the work that I've done very quickly is during the whole systems demonstrator. I was a person who was principally responsible for the evaluation of the whole system demonstrator action network, and that's where I became interested in sort of co-design, particularly in having patients understand information that's given to them, and having doctors understand information that's given to them by patients.
Brilliant. Thanks very much. Sabina Das.
Hello. Yeah, I was working on modeling structural connections between the brain areas. So I was working on computational modeling of structural connection or the physical pathways between two brain areas. And I was using machine learning in defining the brain areas. Like normally the brain areas are basically the broad main areas or the anatomical meaningful areas. So I was trying to develop a computational model using machine learning where non-anatomically equal area parcellation can be made on the brain areas. I'm also trying to work on how the structural connections that can be used for determine that between two brain areas, the functional connectivity that got disrupted, that whether there is a like a connection, that the structural connections between the two brain areas and the frequency characteristics of it can answer why two brain areas are not functionally connected. So I'm working on that. So I have submitted my thesis on that. Yeah.
Brilliant. Thank you. Wasim Ahmed. Wasim Ahmed. We can't hear you, Wasim. Maybe we will move on. Next one, Alexandra Mant. Alex.
Hi, everyone. I'm the Institute for Life Sciences Collaboration Manager, and right now I'm doing quite a lot of work trying to help improve the way that the university hosts, manages and is able to process health and social care data. So this is around background of infrastructure and governance. And the reason I'm here today is to understand more about who in the university wants to work with health and social care data in a secure setting. Thanks, Michael.
So right, Mike Hepburn.
Good morning, everybody. I'm new to the university. I'm head of the Centre for Healthcare Analytics, which is based in the business school.
Brilliant, thank you. I've really lost track of where everyone's going now. It's changing in front of me like in real time. It's really useless. Right, I'm going to have to, move on. I think there might be. Oh, Michael, let's go. Yes.
Why don't people who've already introduced themselves just come off camera, and people who need to introduce themselves come on camera? That might help you.
It could do, but I'm almost there. It's done. Okay, there we go. John Robinson. John. Okay.
It looks like he's on hold. He might have gone to a different room.
Yeah, maybe. Okay. Is there anyone who wants to introduce themselves who hasn't introduced themselves? I got a few on my screen here, so let's go for Chris Duckworth.
Hey, so yeah, I'm Chris Duckworth. I'm a data scientist working at the IT Innovation Centre with Michael. Up until last year, I was working in astronomy. So when Francesco introduced himself, I thought it was at the wrong conference. But anyway, I'm interested in machine learning models. At the moment, I'm focused on COVID and how that's impacted admissions models in emergency departments. So there's sort of an emphasis on developing machine learning models, but also understanding and explaining why they make the decisions they make. So
thanks,
I'll do that. I'm also going to quickly say Since we're introducing a lot of people here, I've added a section at the bottom to do a 1-sentence sales pitch. So please add your name and a quick sentence on what you do so no one gets lost while we're doing all these introductions, because it can be quite a lot of information.
What a great idea. Thanks, Chris.
No problem.
Making this up as we go along, obviously. Chris, the other Chris Kipps.
Hi, I'm Chris Kipps. I'm the Associate Medical Director for R&D at the Trust. Amongst other interests, the one that I really focus on in terms of this session is trying to liberalize and liberate the Trust healthcare data so that it can be utilized most effectively in research. So it's again linking to what Alex said. It's the sort of the other side of the coin, and obviously Michael plays into that as well.
Yep. And just to finalize, let's just get some Alexandre Augustin.
Can you hear me?
Yes.
Oh, hi. Yeah, so basically I'm a postdoc working for Francesco Shankar and some clinicians in London working at the St. Thomas Hospital. And we're basically developing quantitative strategies to optimize blood pressure management strategies. So we're looking at measurement error and physiological variation between individuals. So we're looking for collaborators, clinicians in particular, who provide us with data or a particular problem for us to work on.
Okay, thank you. Mazen Ahmed.
Yep. Hi guys, I'm currently a undergraduate in maths and statistics whilst working part-time as a health data scientist with Michael on a project called MELD, just looking at sort of using machine learning and AI to do multi-morbidity analysis. Keep it short.
Thank you. Yep. Francesco Forcioni.
Hi, I am a hematologist, academic hematologist, interested in behavior of B cell cancer, so lymphomas and leukemias. We are very much interested in one molecule and the changes of this molecule called the B cell receptor, how they relate to many different aspects, including clinical behavior. This means associating the structure with multi-parametric information like genetics, epigenetics, any form of sequencing data, so big data analysis, and correlate those pieces of information with biological algorithms and pathways, but very much also with the appealing part is always distinguishing clinical behaviors, so who goes bad and who goes well. Yep. And so we are always struggling as clinicians in making the question that appears very simple in how to pulling it up. To pull all this huge amount of data, we think it's simple, it is not, and we never do that. And how to process this data in a short time is quite important.
Absolutely. And finally, on my list anyway, Honora Smith.
Hi, thanks, Michael. I'm from maths and part of COMSIS, which I think your name's been mentioned with summer projects, things, yeah, last year. And I'm working with Edelson Fernandez, who probably introduced himself before I arrived, and Mike Hepburn from the Centre of Healthcare Analytics. But we've got some work coming up with a company that's doing the sensing for some remote sensing in a healthcare environment, and I'm wondering if who would be good to talk to from the machine learning point of view, say within your centre, or I don't know whether there's a different centre that would be good to talk to people about machine learning. Or
yeah, so there's a number of connections. You have ourselves, but also Kate Ferrari, who was presenting earlier. Yeah. I tell you what, if you put into the notes of the meeting what you're looking up, we can follow up afterwards, because much of this conversation is about making links and connections.
Yes.
As
Yeah.
Jing was saying at the start, it's about making dates, but certainly
Yeah.
we'd be happy to talk further about that.
Yeah, brilliant. Thanks very much.
So can we all put cameras back on again now? I think we've done all the introductions. I would like to open the floor, really, because you've heard of what everyone said. Has anyone made any links in their minds about people they would want to talk to and follow up? All right. Is there anything you've heard where you're thinking, right, a bit like that conversation I had with Honora just then? I think it's the time to sort of make that open. If anyone's got anything that they're thinking about.
Shall I kick off, Michael? I think one of the things that's exciting me is what Chris Kipps was mentioning, which is this data trust and the access to data for people from across the university. So I think that's quite an exciting thing to hear about.
Okay, do you want to follow up on that, Chris?
Yeah, sure. So look, what we've been working through is just trying to work out how you actually access this data in a way that is appropriately governed, because one of the things that really blows us apart is that if you get the information governance wrong, then everything else becomes impossible. So we're just working through overlapping the governance with some aspects of the technical architecture, but there's very definitely an ambition and an intention to move this forward, and there's some practical steps that have been taken by a range of people within the trust and also in the university to try and do this. So I think you will find that over the next 12 months that actually there are mechanisms to access data within a trusted research environment that will mean that you can manipulate the data, but that you do it in an environment where you're not going to breach any information governance rules, and that's kind of in progress. So I guess that's probably the simplest summary of it.
Have you, I just wondered, Chris, have you spoken to, Alex has mentioned, that there's something going on in the university. I just wonder whether that's a conversation that you've had via Peter Smith.
I think it's probably the conversation via Peter, but Alex and I have not directly talked about it. So actually that is one of those links that would be very useful to tie up.
So one of the things that is happening in Southampton, as Chris has alluded to, is work on developing a trusted research environment to share data, but also the council and the hospital and the university have just signed a memorandum of understanding to work towards what's called a social data foundation for our region, or our city at least. And that is a thing that's been led by the Web Science Institute and Wendy Hall, working with Chris and Neil Tape and others in the hospital. So I think, as Chris says, over the next year to 5 years, where these things take time. I think the environment into which we do data science is going to radically change to something that's far more managed and hopefully allows us to do far more with the data that we're collecting. So that's one aspect I think that comes out of this, and I think we could share more information with you all about that as it proceeds. So maybe we want to somehow collect that. I'm interested.
Michael, just a quick follow up, if I may.
Yes.
Chris, are you aware of the review that Matt Hancock's ordered with Ben Goldacre? Is that something that you guys are feeding into?
Not specifically. In terms of data access.
Yeah, there's the Goldacre review. I don't know if it's going to have the level of punch that the Caldecott review had, but they're looking at how to improve and speed up access to data, or health data specifically. Hancock announced it in the beginning of February, I think it was. I think Ben Goldacre's got quite a pedigree in this area, but I just wonder if it's something to sort of engage with.
Do you mind sending me some details? Because no, it's not directly on my radar. So
yeah, sure. I'll do that.
May well have some relevance.
So is anybody else working? I mean, we've got two things. We've got the data infrastructure and governance frameworks, but then we've got the applications that need that, in a sense. And some of you represent, let's say, the environment, and others represent the applications. But is anyone else here who has something to say about essentially the data infrastructure and data infrastructure management? Okay, so we'll leave that particular piece there for now. What I'm really interested in is whether there's clinicians with data challenges, which I've heard many in the introductions, and data scientists, or whatever you want to call yourself this week, whether there's any connections that have been made. Has anyone heard something that's saying, well, I can solve your problem for you? Or
If I may, so obviously we always come with a simple question and a complex answer. But if any of the data scientists, engineers, whatever we call them, will be able, I'm appointing a data manager / data scientist who will have to elaborate big numbers and will need to be instructed by a clinician like me. I've always worked in looking at survivals, but on parameters that already they are available. And that's a data management effort which doesn't require the big effort of elaborating them together. Now we are moving to the next step, and if there is someone who would like to help and engage with this new appointed person,
sorry. Can everyone go on mute if they're not talking?
Well, unfortunately, it's my stupid telephone.
Oh, it's your phone. So you go.
Yes. So it was my fault.
Carry on. So you're hiring someone.
Yeah. I'm actually, the job is advertised. So if there are people within that interface, they would be very much welcome. So they would directly work with you and myself in order to elaborate data, big data.
Okay, that sounds interesting. I mean, there's a number of opportunities there. I think in terms of, yeah, there are people around, absolutely, who have that interdisciplinary skills that cut across big data and health data science. So I think that's certainly something to follow up. And also to put a shout out across the whole of ECS, to be honest with you, because there's capabilities across the whole school and even the university. We've heard from others. So that's definitely something to follow up. So thank you for that. So for the clinicians or those with clinical problems in this room, is anyone able to articulate their data related challenges or their unmet needs? I mean, a bit like Francesco's just said, we've got huge amounts of heterogeneous, diverse, large data sets, and we need to figure out the best way to use it in a general sense. But I'd welcome others people's views of the sorts of problems that you're facing. Go on then, Chris.
I mean, the area of interest I've got is in brain imaging. So we do a lot of brain imaging for dementia diagnosis, and there's a need to do reporting of that and to structure it in a particular way. So machine learning processes that can help with automated reporting of some of the diagnostic images would be particularly useful because it alleviates a workload. And then there is a degree of complexity and subtlety about some of the imaging which leads to further uncertainty, such that you can't make a decision on today's image, but you might be able to make one on the same technique repeated a year later. And so there are, I'm sure, patterns that we can't really work out at a clinical level that a machine could do a better job at, and it would be helpful to be able to use that as well as a sort of risk stratifier, I guess.
Yeah, I mean medical imaging is a type of data, it's a type of expertise, I think. I mean, in the world of data science, it requires certain infrastructure, certain types of algorithms, and it's particularly good for machine learning and neural networks and the like. Is there anyone on here who comes with that background? It's certainly not me, that's for sure. We've not done that. I don't know whether, Chris, you've done any work in the past from your galaxy evolution studies, and whether you can see any parallels of that and medical imaging.
Well, I worked on a couple of projects taking a galaxy image, so it doesn't really matter that it's a galaxy, but it's using convolutional neural networks to sort of describe what are the interesting features in that image. And once you have a descriptive set of features about the image, it doesn't have to be just with an end goal of using this model that gives you this singular output. Once you have these features, you can also cluster similar images together. So there's a whole host of different avenues that could go down.
So yeah, I mean, we've got tens of thousands of images that could be used for this in various ways. But so it would be an interesting approach, because I'm sure that there are features that can be identified that can be used as classifiers.
Amazing.
Tina.
So we have done, as part of our vascular imaging and lymphatic imaging projects, we've looked it from two-pronged approach. One is we take the image and run very heavy-duty models on it to assign function. And those are physiological-based models that take some time. But then we correlate it to fast morphometrics from the images, so that we can select what features, what fast morphometrics, because there's a whole zoo of these around, you know, tortuosity of blood vessels, length, density, diameter, average things. Which one of the fast morphometric measures correlates best with a function that you're interested in? So it's that true approach that is very useful, particularly for vascular function, that we've done. It might be useful for brain imaging as well. The caveat there is that to really reliably do that choice of fast morphometrics that will be quick in the end, you do need to do this longer studies beforehand, where you do the actual physiological simulation in 3D. So, I mean, am I making sense, or do I explain a little bit more?
No, I think that makes sense. I mean, there is a fair amount of connectivity data, which is kind of allied to this, that already exists. I mean, people have spent a huge amount of time and effort in defining the local and the longer connections.
Yeah.
But you can use that as prior knowledge, I'm sure, to bias your learning. So I think, you know, knowing something about the, you know, you've talked about blood vessels, knowing something about the anatomy of blood vessels and how areas develop together and therefore link together and therefore function together is actually really important in working out how they degenerate. And sometimes the degeneration is along these natural pathways, and sometimes it's because one pathway happens to sit next to an adjacent one. So I think, you know, having that knowledge and being able to incorporate that into a model would be quite useful, very useful.
Yeah, so I'm happy to help if that approach is useful for anybody. It's not that the ultimate result is going to be quick analytics on the data, but to get there, you need to do the slower bits as well, which is, I don't want to kind of give false hopes to anybody that it's just that let's send off the machine learning algorithm and it'll give you all the answers. It isn't.
Absolutely right.
But eventually it will be. That's the point.
That sounds like a really interesting conversation to follow up with afterwards. Kai, you've put your hand up. I'd be
happy to.
Yes, very, very interesting indeed. And just want to say a few words with that regard of the data that raise of connectivity from Dr. Kipps and vascular data from Dr. Roos, that from a neuroimaging perspective, the functional MRI data provide a signal that actually contains neurovascular coupling information, and also can be inferred to study how brain functions, the functional connectivity. It entails the full spectrums of the frequency. So the big question here for data science, and I kind of like to throw some provoking some thought, it's how to standardize a pipeline, and how to make this pipeline easily accessible to different research groups who may have ideas and want to study this, for example, the vascular aspects of the MRI signal or the connectivity aspects of the brain signal. And if using different pipelines to process the data, it might get different results, and very hard to reach a consensus and understand this. So yeah, so my thoughts, my current thoughts with my trainings in neuroimaging and particularly MRI is, yes, we have loads of data, but we also need to come up with a way to better reproduce all the analysis and there are loads of very good publications out there, but and how to get the conclusions that is useful for clinicians, and how to make the fMRI more interpretable from clinician point of view. There are a lot of data that is kind of hard to interpret. They're certainly very interesting.
So you've made a really excellent point that links to the trusted research environment, which we talked about earlier, providing ways into it's not just about producing the paper. The outcomes of your research need to be reproducible, and the pipelines, or the AI processes, call them, that whole engineering, how you pre-process data, all the steps you take to select and slice, and needs to be recorded as part of provenance of your research and shared, so other people can either repeat it in other ways. And then we know that it's incredibly important for the safety.
I echo that 100%. Yes.
What we've talked with H. Chapman about the provenance, the work stream provenance management related to images, to the outputs, because there's virtually, my understanding, H is here, isn't she? That there isn't a simple platform from computer science point of view. There isn't a platform that easily captures the provenance of human machine in sort of knowledge transfer in that pipeline. That is actually, we tried in our group when we're doing our two-pronged approach to implement something there. A, there isn't a tool really that does it, and B, it's too time intensive, and the burden of learning is too heavy on the persons actually doing it. So it's an excellent example where we need more computer scientists or computer systems engineers really to help scientists.
Yeah, absolutely. I want to bring Hans in. Hans, you've had your hand up.
Just to interject quickly, in the essence of time, I think we've got a couple of minutes left, so we should probably think about wrapping up. But I would encourage people to continue these conversations in the chat or the Google Doc, or individually, whatever makes sense. But yeah.
Thanks, Chris. I think Hans, come on, let's get you in. You've had your hand up.
I have more probably a simpler problem, or simpler request. So we have this watch database, and hopefully now collecting also this MEP study database. But ours is in an Access bespoke database that was run by one specific data manager who's now retired. So we have an SPSS file of the data, but we have little access to this bespoke database. Yeah. So to have access to databases for clinicians, or make them easily accessible, this would be my request. Or I don't know if there are solutions where you have data sets that are in an Access or that has been run by one person, can be made accessible for clinicians so that they can easily look at them and actually take data out that they think are important.
Okay, I mean, there are different solutions for increasing accessibility to data sets from various different sources, and I'll follow up with you, Hans, on that particular case, because it typically might be a case-by-case basis, but it is something that we could think about, Chris, as Chris Kipps on this case, is what sort of assets we make available and advertise as part of the trusted research environment. There could be imaging, or there could be this bespoke data set, but there is a huge understanding what all these assets are is going to be part of the next journey, I think.
Thank you.
So we are 11:30, and that's, I think, is our time, Chris. That's Chris Duckworth.
Yeah,
correct?
I believe so.
Okay, so thank you very much for your time. But any other notes, put them into the text. We'll try and collect what's been discussed, identify those connections as based on the introductions and what we've heard, and maybe even make some suggestions about who you might like to talk to afterwards. But thank you for your time. Thank you.
Thank you.